Time for some binomial expansion fun. First goal, let's find the binomial series expansion for the square root of 1 plus x. And then we will modify that to find the expansion for g. So first off, we need to know that when p is 1/2, which it is because square root equals a power of 1/2, then this will be the interval of convergence. For a binomial series, we can't use the ratio test like we normally do to find that interval of convergence. This will always be provided for us. So the function f of x, if we want to expand it as a binomial, it will be, in general, p choose 0 plus p choose 1 times x. It's going to look a heck of a lot like a geometric series with modified coefficients. Instead of the standard geometric series coefficients, we have these binomial coefficients. So for us, we are going to have a p-value of 1/2, so we will have 1/2 choose 0 plus 1/2 choose 1 times x plus 1/2 choose 2 times x squared, etc. So we need to figure out these coefficients. We will come off to the side to do that. Let's come up here. Well, actually, let's do the first two instantaneously. 1/2 choose 0 is 1. There's only one way to choose 0, and that is to choose nothing. 1/2 choose 1. That will always be p. And now the two that we have to compute are the 1/2 choose 2 and the 1/2 choose 3. So 1/2 choose 2, we start at 1/2, and then we do repeated subtraction by 1 until we get to 2 factors. So this will end up being minus 1/4 divided by 2, which is minus 1/8. So that will be this coefficient. And then next one's going to be negative, so let's do this. Come up here, 1/2 choose 3. Same start, we do 1/2 multiplied by negative 1/2. We do repeated subtraction of 1 until we get 3 factors. Divide by 3 factorial. And yes, I can hear you screaming in my ear, that's negative and that's positive. So that will give us, in the numerator, we will have a positive 3 divided by 8. And if we take 3 divided by 8 and divide it by 6, we'll have that, which will simplify to 1/16. This will be the coefficient for x cubed, etc. The next term will in fact be negative, so I'll put a negative there. So there we go. There is our series expansion for the square root of 1 plus x, and the interval of convergence here is going to be -1 to 1, including the endpoints. So let's go ahead and do the second part of the question. We want to find a series expansion for a binomial series expansion for 1 minus 4x. So 1 minus 4x, that's g. We are going to replace all the x's in the series expansion for f. All those x's are going to be replaced with -4x. So we're going to come on through and replace all the x's with -4x. This will be the expansion for g. And frequently we don't simplify these types of things. In this case, it's simple enough to do it, so we'll go ahead and do the simplification. Sometimes we just don't, sometimes we do. There's no great rule of thumb. So this term here, -4 times -4 is +16. 16 divided by 8 is 2. And then over here we have negative 4 squared, which is, yes, I hear you. Over here we have negative 4 cubed, which is 64 with a negative sign. So negative 64 divided by 16 is negative 4 x cubed. And then this is going to continue on forever. Now we have to modify our interval of convergence. The original interval of convergence was negative 1 less than or equal to x less than or equal to 1. We replaced x with negative 4x, so we need to do the same thing in the IOC. We'll divide through by negative 4, which is going to reverse the inequalities. So we will have this. And our conclusion is that our interval of convergence will include negative 1/4 and go all the way up to and include positive 1/4. So now we have our series expansion for G, and we have its interval of convergence, and that is it.